So kind of, that's not bad, right? So now let's go across, down, across, down. There's a movie called Stand and Deliver. It's about a man in XYZ, California. Someplace in California. Very tough, probably Los Angeles. It's a very tough neighborhood where the kids went to school. This is an old movie. The kids went to school. Right. Just if you ever have 5 minutes and you want to watch something from the 80s, that's a really good movie. 5 minutes. You might have
a slow time
Give or take an hour.
It would take 2 hours. You know, honestly, it's probably one of my favorite movies that I've ever. As a matter of fact, right after he taught this, he walked down the stairs at his school and had a massive heart attack and was in the hospital for a while. And the kids continued to teach themselves while he was out in his honor. It was just a cool movie. Just a cool movie.
That was cool. Like, 'cause my dad was just scrolling through the TV and he's like, oh, you know, the math teacher, I don't remember his name. And like, I've never heard of that. And then I started watching my husband.
Now we have an answer here, right? So we have negative 1/3 x e to the negative 3x. Make sure I'm doing it right. And then minus 1/9 e to the negative 3x. But the problem we had was we don't put plus c because we have an a and a b. No a and a b, use a c. So we have from 0 to the ln of 2. So, very good. From 0 to the ln of 2. That means I have the integral complete. I'm going to assess it. So I'm going to plug in ln of 2 first, all the way across. I'm not going to clean it up until it's absolutely necessary. Okay? So we have negative 1/3 ln of 2 e to the negative 3 ln of 2. Oh, minus 1/9 e to the negative 3 ln of 2.
And then put parentheses around that and then plug in your 0.
Correct.
But the 0, I don't think,
Well, we'll see.
doesn't,
Never
sometimes
be.
it does things.
Sometimes it does things, sometimes it doesn't. In the first part, 0 times anything,
0.
0. So I'm just going to put minus 0. You guys cool with that without me showing it? 1/3, 0, e to, right. So, okay. And then minus e to the 3 times 0, so 0. That does something. Oh,
1.
Minus 1/9. That does something else, too.
Yeah.
All right, so far so good? Anybody lost?
Nope.
Now, over here, I think you guys would agree, negative 1/9 and e to the 0. Anything to the 0
Is 1.
is 1. So minus 1/9 e to the 0. So minus 1/9, really, plus 1/9. So I'm
Yeah.
just cleaning that guy now. That makes me feel better. Yeah, so far so good, right?
You just have to plug all that in your calculator on the left side.
You just have, well, you know, let me talk to you a little bit about something. Well, you know. Okay.
Oh, can't you just leave it like that?
Yes, but I want to show you how it's easy clean. Yeah.
Don't, because like when you do the interval e, you take what's on top by the reciprocal.
Which we did right here, the 1/3.
Yeah. But
Yeah.
I'm saying can like that.
Can it go away?
Yeah.
Well, the integral's done. We're just mathing it now. We're just plugging the thing in. Yeah. But I want to talk to you a little bit about the properties that I started with before the hurricane. Do you know that I have a number in front of ln, and there was something called the power rule that you guys learned for the ln stuff, which told me that if I have something in front of ln, it can come up here as an exponent, or if it's up here, it can come down here. So really, this 3 could be like to the negative 3 here, and then this 3 could be to the negative 3. Are you with me? Now, I don't know whether I did this very well, but anytime you have an E and an ln touching, like this manner, they actually get rid of each other. They're inverses. So let's see on your calculator. If you did e to the ln of x, So if you put e to the ln of x in your calculator, it comes out as x, because these two guys cancel and you're left with x.
Mhm.
If you do e to the ln of 3, what should the answer be? It should be 3.
Mhm.
Make sure, check it in your little calculator, make sure. E to the ln of 3.
So it's just 2 to the negative third, and the e and the ln go away.
Right.
Yeah, what else?
1/8.
Yelling.
Okay, what do you get when you get e to the ln of 3? Did you get 3? Did you check me out? Make sure I was right?
Mm-hmm.
Does anybody know what the e button looks like on their
Yeah.
calculator? It is 3,
I
right?
don't know where the LN button is.
LN and 3 are usually the same button.
Oh, it is?
Oh, that's
Okay.
funny. Okay, so this is negative 1/3.
Oh, yeah.
Are you guys with me? ln of 2 is just some crazy number, like 0.69, blah, 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 blah. E to the ln of 2 to the negative third is 2 to the negative third. What's 2 to the negative third?
1/8.
1/8,
Mm-hmm.
right?
Mm-hmm.
Minus 1/9 e to the ln of 2 to the negative third, so times 1/8
Mm-hmm.
plus that. I don't know how clean they made it on your answers.
Pretty clean, very clean.
Pretty
Well,
clean?
you can take the ln of 2 and just, there's just a lot of algebra going on from here.
There's a lot of algebra going on, so let's. So right here, what do we have? The 1/8 and the 1/3 come together as negative 1/24,
Mm-hmm.
Negative?
ln of 2, right? This is minus 1/72 plus, do you guys agree, 8/72?
Mm-hmm.
So minus 970 seconds.
No, it'd be plus, right?
Plus,
Yeah.
it would be 7. Negative 1 plus 8,
Um,
yeah. So negative 1/24, I'm with you, ln of 2 plus 7/72. I don't know how far they
I
got.
think that was.
That's the answer. Yay.
So they don't want us to take the ln of 2?
No, of course not. That would be too clean.
Yeah, I think that's what they got.
What do you think? Was that horrific?
So, do we have to get down to that, or can we leave it
Um,
above?
On the AICE test, on this test, I have a couple bonus questions. If that gives you a good hint.
Oh, so, okay.
I would. We'll do another one. We'll do another one, make sure you get it.
So we don't have to worry about the ones that go to infinity?
No, I would not put that on there.
Because it-
Wait, on the
number
ACE
4
test,
is
will we
what-
have to clean it?
the
Or
answer is-
Sometimes, yeah.
sometimes?
Okay,
14 are we gonna do?
14. Yeah.
I wish they had more.
Oh.
Did you need me to do it your way though?
Yes.
Okay, so you tell me, let's go ahead. I'm not gonna assess it. I'm not plugging stuff in.
Yeah.
Because
no,
you should be
that-
there. Okay.
So we're at 14.
So you fill in 4 categories. U, DU,
And then
DD, and V, right?
does
So-
it matters if you put the DV before the V?
Uh-huh.
Okay.
So which one do you want to call U?
X,
Okay, the reason why you choose X,
because it derives to small.
it becomes smaller, right? So the derivative of X is 1, so 1 dx actually. Okay, and then dv is what's left over. It's e to the negative 3x, okay.
It's just the same.
the dx here.
Oh, 1/3.
So yeah, it's negative 1/3 e to the negative 3x, right? Now, you're going to do uv minus the integral of v du. So this times this, so negative 1/3 x e to the negative 3x, so far so good, minus the integral of v, negative 1/3 e to the negative 3x, and then du, which is dx.
This okay?
Yes, baby.
I thought when you did the v that it would be negative 3 e to the negative 3x. Because don't you would take the derivative of the exponent and then stick it in the front?
But remember, we're integrating, we stick it in the front, but when we integrate it, we have to pull out its reciprocal.
Put it on the bottom.
Right.
Yeah. Does that make sense?
Mhm.
That's where the 1/3 comes from.
And if it wasn't so like clean, like if it was a bigger number for the thing, you would put it in front of the dx, right? Okay.
Yeah. Like this guy right here, -1/3, I'm gonna pull out and make it positive 1/3 here. And then I'm gonna go, uh-oh, I need to take an integral, and right here I need a -3. Okay, so if I insert yet another -3, I have to pull out a -1/3. And that's where that -1/9 comes from.
Okay.
Okay? So I would put in a -3 and pull out a -1/3. Does that make sense? So then you do that, then the integral of that would be e to the -3x. You with me now? So you're at that place where you should kind of recognize
Where it looks
this,
the exact same. with
they're
that.
the same, right? Does that make sense?
Yeah.
Cool. Good stuff. All right. So 14. 14. It's because it has a pi over 4. We're doing it, right? That's what I thought.
But it's sine and cosine, so it shouldn't be too bad. It shouldn't be that
Put
one.
a
It's
sign
got five
and
on it.
a regular.
I think, yeah.
Next to them, sorry.
Yeah.
Oh, well. Practice won't hurt.
Okay. Now what?
Well, you can use the tabular method because you've got something that is derivable to 0.
Yeah.
Yeah.
Yeah. So we're going to do tabular method. Okay. So plus minus, however many you need. Your u is x. Your dv is sine of 2x dx. Are we good? The derivative of u,
1,
1,
0.
0. I don't need that last sign. Are we good there?
Uh-huh.
And then we're going to integrate the sine of 2x. So the integral of sine, what is the integral of sine?
Is it
Negative
-1/2 sine? Or
Negative one half
Negative.
cosine.
cosine?
Negative 1/2.
Cosine.
Cosine
Yeah.
of 2x.
You guys are feeling it?
Mm-hmm.
Yeah.
And
See-
-1/4.
One thing I
Or
noticed.
sine, sorry.
One thing I noticed is when you're going from sine, when you start with sine, you go sine, negative cosine, negative sine, and then with cosine,
Yeah,
you
it's every
go,
time.
you go cosine, negative sine, cosine.
Yeah,
As long as
every
you do
time.
that pattern.
Every time.
As long as you know your pattern.
Yeah.
So it goes positive, negative, negative.
Right.
positive.
Right.
And they just intertwine.
They
Yeah.
do. And so what's this guy going to be?
Negative 1/4
1/4
sine
Sine
x.
2x.
2x.
Are we feeling okay?
Yeah.
I think this one's easier than the last.
I think so
Yeah,
too.
this part is.
Across
Oh, no,
and
it's not
down,
that
across
easy.
and down. Tic-tac-toe, 3 in a row.
Look at this now.
Now you know where my brain goes. So I have negative 1/2 x cosine of 2x, right? Plus 1/4 sine of 2x from 0 to pi over 4.
Yes. Which is really nice because everything's multiplied. Oh my goodness.
Becomes pi over 2.
Yeah. Everything's multiplied together. So when you plug in the 0, it just all goes away.
Cancels the 1. It cancels the first one because it's a 0.
Right.
And then the second one, sine of 0. What's sine of 0?
Oh, wow. What is
That's a 1. isn't
One.
it? Or no. It's 1, 0. It's a 0.
It's a 0.
Yeah, let's clean her up. So we're going to put a pi over 4, so negative 1/2 pi over 4, cosine of pi over 2, basically, right? Because 2 pi over 4 is pi over 2.
Yeah.
Plus 1/4 sine of pi over 2. Minus parenthesis, don't be complacent.
And so it's
Wait, how
minus.
come we just did pi? Like,
Yeah.
You forgot the 4.
Yeah.
What's
Pi over 2 because it's 2 times
for the
pi over
first
4.
one, yeah.
But shouldn't it be pi over 4 for
Okay.
the first one?
With the 1/2.
I get it.
Yeah.
I'm confused.
Oh, here, pi over 4?
Yeah.
Thanks.
Would it be? Okay.
I think that's what they were talking about.
Could you
Good catch.
Maybe it's pi over 8, negative pi over 8.
Yeah. And then 0 into here is 0.
Mm-hmm.
Because it's that times 0 times whatever. So 0 times anything is 0. So there's my 0. And then now if I plug 0 in here, it's not necessarily 0, but I want to make sure.
this case it
It is because it's sine of 0
Zero.
is 0. So this is plus 0.
Divide that 0 by 4.
Right, we gotta make sure we take the 4 into account. So what does this turn out to be? What's cosine of pi over 2?
That's 90 degrees.
90 degrees.
Cosine is your x value,
So that
0.
means I'm starting here and going straight up. So my ordered pair is
0.
0, 1.
Yep.
So cosine is just a, so right.
So it's what?
So this is 0.
Plus
Oh.
1/4.
Which means everything.
So this is 0, right?
Mhm.
Man.
It's 1/4.
Plus, and yeah, what's 1/4 of sine of pi over 2? You said is 1.
hmm
So times 1.
That's pretty nice.
That was a pretty one. It was very pretty. I like that a lot too.
That looks like 1 over y for the answer.
It does, because the handwriting is obviously lacking today.
Wait, do you know that the sine of 1 over or pi over 2 from like a unit circle?
Yes.
Okay. I was just making sure.
So I had to rewrite it so many times to the point
Your
where
unit circle,
Yeah, pi over 2. Okay.
right, because it's x and y, which is cosine sine.
Okay.
So are we finished with the going over
Good,
problems?
so you guys feel comfortable?
Yeah.
On Monday, we'll pull them all together. We'll just do a bunch of problems.
Ms. K? So how many problems do you suggest that we do over the weekend?
I gave you the other worksheet with the integrals, right?
yes.
The one that said D. Joyce on it?
I don't know. There's one.
The one that had that college on it.
Yeah.
Okay, I gave you that. I gave you one with derivatives.
What's this page?
I think the test is going to be probably Thursday.